So I'll show you how to use these conditions in order to work out the unknown constants which are part of the general solution. But first of all, let's get the general solution to the second order differential equation firstly, okay? So remember the steps. So in step number 1, remember, let fx equal 0, okay? So back to the paper and pen. So here is our f of x, the function on the right hand side of this equation. So in step number 1, let me let f of x equal 0 so that this equation, and I'm going to call this equation in question double star. So remember, we named this double star in the previous video. So remember what I said, name the equation in question double star. So if I let fx equals 0, this equation becomes d2y by dx squared minus 2 dy by dx plus 5y is equal to 0. Okay, so I'm going to call this equation star. And let's go back to the next screenshot. So remember step number 2, we let y equals capital A e to the mx, and using this we work out dy over dx as well as d2y by dx squared. Okay, so back to the paper and pen. So in step 2, y is capital A e to the mx, so dy by dx, that would be am e to the mx, and d2y by dx squared, that will be am squared e to the mx. Okay, so that takes us to step number 3. And remember step number 3, so back to the screenshot. Step number 3 is to put our results for y, dy over dx and d2y over dx squared into star. Okay, so back to the paper and pen. So we need to put these results here into this equation which I've named star. So let's do that. So put y dy by dx and d2y by dx squared into star. So here's equation star. d2y over dx squared, we had am squared e to the mx, okay, minus 2 dy over dx, which is am e to the mx, plus 5, and y, which is a e to the mx, and that is equal to 0. Okay, so that takes us to the next step, which is step number 4. So let's remind ourselves step number 4. So back to the screenshot. So remember, we cancel by a, so remember a is a constant, and as e to the mx is non-zero, we get the auxiliary equation. Okay, so back to the paper and pen. So if I cancel a, since a is a constant, and as e to the mx is non-zero, our auxiliary equation is m squared minus 2m plus 5, and that is equal to 0. So remember, in the previous video I mentioned that depending on the solutions to this auxiliary equation, we need to select one of the 3 cases for the complementary function ycf. Okay, so let's work out the solutions to this quadratic. So we can't factorize this quadratic, so we need to use the quadratic formula. So let's use the formula. So m is equal to minus b plus or minus the square roots b squared minus 4ac over 2a. Okay, so that's our quadratic formula. So a is the coefficient of m squared, being 1. B is the coefficient of m, which is minus 2. And c, the constant, which is plus 5. So if I substitute a, b and c into the quadratic formula, we'll have m is equal to minus b, which is minus 2, plus or minus the square root, b squared, so b is minus 2, so minus 2 squared, minus 4 into a, which is 1, c, which is 5, divided by 2 of a, which is 1. Okay, so I substituted a, b and c into the quadratic formula. Okay, so if we simplify this, let's see what we have. So m will be minus into minus 2 is plus 2, plus or minus square root. Okay, and minus 2 squared is 4, and 4 minus 4 times 1 times 5 is 20. Okay, so 4 minus 20 is minus 16. Okay, so that is the term under the square roots, divided by 2 into 1, which is 2. So remember in the last video we had one of these cases for YCF for one of the examples. So remember, if you have a negative under the roots, okay, what should strike in your minds is the result I squared is equal to minus 1. Okay, so I is an imaginary number. So if we use I squared is equal to minus 1, we could rewrite minus 16. On the basis of this result, we can rewrite minus 16 as 16i squared. Okay, so let me rewrite that as 2 plus or minus root of minus 16, which is the same as 16i squared divided by 2. Okay, and if I continue along this line, we'll have 2 plus or minus root of 16i squared is 4i, okay, divided by 2. So if I divide each of these terms in the numerator by the term in the denominator, which is 2, this is what we're going to have for m. So if I continue on the reverse, m will therefore be, so again if I divide each of these terms by 2, 2 divided by 2 is 1, plus or minus 4 over 2, which is 2i. Okay, so we're going to have 1 plus or minus 2i. Okay, so here are the solutions for m. And if we go back to the screenshot quickly, so remember we had complex solutions for m, so this means that we have case number 3. Okay, so remember, if m's equal to k1 plus or minus k2i, so if you have complex solutions for m, your complementary function will take the form e to the power k1x, open a bracket, a cos k2x plus b sine k2x. Okay, so back to the paper and pen. So here is k1. So k1 is the real term, which is 1. And k2 is the imaginary part of your complex number, which is 2. So our complementary function YCF, remember, is of the form e to the k1x into a cos k2x plus b sine k2x. So if I simply replace k1 by 1 and k2 by 2, we're going to have e to the power k1, which is 1x, into a cos k2, which is 2x, plus b sine k2, which is 2x. Okay, so the choice of YCF I named that step number 5. Okay, so we've completed step number 5, so 5 steps involved in order to work out the complementary function YCF. So let's go back to the screenshots. The next step, step number 6, remember, in the previous video when we did examples, is to choose YPI depending on whatever you have for f of x. Okay, so we've talked about these cases illustrated in this table. Okay, so let's go back to the paper and pen to see our form for f of x. So our form for f of x is 10x plus 1. So f of x, in other words, is a linear. Okay, so let me make a note of that. So in step 6, our f of x is 10x plus 1, which is linear. So if we go to the screenshot quickly, so since our f of x is of the form ax plus b, where a and b are constants, we need to take ypi to be linear also. So we need to choose ypi to be px plus q, and p and q are constants that we need to calculate. Okay, so back to paper and pen. So we're going to take ypi to be px plus q. Now, if we go back to the screenshot, step number 7, remember, is to use our ypi and calculate dy over dx using our ypi, as well as d2r by dx squared. Okay, so let's go back to the paper and pen. So in step number 7, our ypi is px plus q. So using this, dy over dx. So again, bearing in mind p and q are constants, when I differentiate, we simply get p. And d2y by dx squared, if I differentiate p, which is a constant, we'll have 0. Okay, so step 7 is complete. So this takes us to step number 8. So back to the screenshot. Remember, step number 8 is to put our results for y, dy over dx and d2y by dx squared into double star. And remember, double star is the main equation that we have in question. So back to the paper and pen. So looking back, double star is this main equation here. Okay, so here's our equation double star. So we need to put our results for y, dy over dx and d2y over dx squared into this equation. So let's do that. So put y dy by dx and d2y by dx squared into double star. Okay, so when we do this, this is what we're going to have. So it's d2r by dx squared, and that is 0. Okay, minus 2 of dy by dx, so minus 2, and dy by dx is p. Okay, plus 5 times y, so plus 5 times y, which is px plus q, and that is equal to 10x plus 1 on the right hand side. So that's equal to 10x plus 1. Okay, so remember in the last video I said group the like terms on both sides. So what I mean by this is we need to group the x terms and the constants on both sides of this equation. So the right hand side is already grouped. Okay, so let's group the terms, the x terms and the constants on the left hand side. So I have one x term, so which is 5px. So I'm going to write this as 5p in a bracket with x outside, plus, and let me group the constants. So I have a minus 2p, so a minus 2p from here, and plus a 5 times q, so plus a 5q. So these are the constants that we have on the left hand side. So we've collected the constants, we've collected our x terms on the left, and we have 10x plus 1 on the right hand side. Okay, so this is what I mean by grouping the terms, the like terms, so grouping the x terms and the constants on both sides of the equation. Okay, so once you've done that, go to step number 9. So if we go to the screenshot, step number 9 is equate the coefficients of the like terms to find p, q and r if you had another unknown constant. Okay, so if we go back to the paper and pen, so if I equate the coefficients of x, so we have terms with x and constants on both sides. So equate the coefficients of x and constants on both sides. So I use c to mean constants, okay? Since we have, in this case, only x terms and constants appearing on both sides. So let me first equate the coefficients of x on both sides. So if I take a red pen, the coefficient of x on the left hand side is 5p, and the coefficient of x on the right hand side is 10. So 5p is equal to 10, and straight away p is therefore 2. Okay? Let's do the same with constants. So let's equate the constants on both sides. So the constant on the left hand side, so highlighted in green, is minus 2p plus 5q, and the constant on the right hand side is plus 1. So in this case, minus 2p plus 5q is equal to 1. Okay, so you can name these equations if you want, 1 and 2. So if I put p equals 2 into equation 2, let's find out what q is. So let's do that. So if I put p equals 2 into equation 2, we have minus 2 into p, which is 2, plus 5q, which is equal to 1. So in this case, when I simplify this, minus 2 times 2 is minus 4, plus 5q, which is equal to 1. So if I take the minus 4 to the right hand side, 5q therefore is 5, which means q is 1. Okay, so this is the value of p. Our p value is 2 in this case. The value of q is 1. So if I replace the p and q values into our particular integral ypi, this is what we're going to have for ypi. Okay, so therefore ypi, so remember ypi is px plus q, so the p value is 2, so it's going to be 2x plus q, which is 1. Okay, so this takes us to the next step, step number 10. So let's go back to the screenshot. Remember, step number 10 is to work out the general solution, you add your complementary function to your particular integral. Okay, so back to the paper and pen. So the general solution, that is y is ycf plus ypi. So let's go back quickly. YCF, we had e to the x into a cos 2x plus b sine 2x. So let's copy that down. So y is YCF, which was e to the x, a cos 2x plus b sine 2x plus, and ypi, we had 2x plus 1. Okay, so that is the general solution for our second order differential equation. Okay, now we've been given some extra conditions. So we've been given these conditions. So when x is 0, y is 0, and dy by dx is 0, these conditions are used to work out the unknown constants a and b, which are part of your general solution. So let me show you how to use these conditions. Okay, so once you get to this stage, so you've done most of the work, it's just a couple of extra steps. So let me start off by substituting x is equal to 0 and y is equal to 0 to get one equation in terms of a and b. Okay, so x is equal to 0, y is equal to 0. If I replace them in our general solution, we're going to have y, which is 0, that is equal to e to the power x, which is 0, into a cos 2 times x, which is 0, so 2 times 0 is 0, plus b sine 2 into x, which is 0, is 0, plus 2 into x being 0 plus 1. Okay, so e to the 0 is 1. Cos 0 is a standard result. Cos 0 is 1. So e to the 0 is 1. Cos 0 is a standard result 1. Sine 0 is also standard, that is 0. Okay, so bearing in mind these, we're going to have 0 on the left, and that is equal to e to the 0, which is 1, times a is a, okay? And 2 into 0 is 0, but don't forget this plus 1, okay? So when you rearrange, the a value is minus 1, okay? So that is the value of a. Let me replace a is equal to minus 1 into our general solution. So this is what we're going to have. So we're going to have y is equal to e to the x into a, which is minus 1, so minus cos 2x, plus b sine 2x plus 2x plus 1. Now we need to work out the value of the remaining constant, which is b, and that is where these conditions come into play. So we need to use the condition now that when x is 0, dy by dx is 0. Okay? So in this case, in order to use this result, dy by dx is equal to 0 when x is 0, we need to work out dy by dx. Okay? So if we come back to what we have here, let's work out dy over dx carefully. Now I'm going to use the product rule for the first term. So for the first term, let's do it carefully using a product rule. So u, I'm going to take that to be e to the x, and v, I'm going to take that to be this entire term in the brackets. Okay? So remember the product rule, it's v. So v is this entire term in the bracket minus cos 2x plus b sine 2x, okay, multiplied by du by dx. So I'll write down the rule on the top, okay. So it's v du over dx. So when you differentiate u, which is e to the x, it's e to the x, okay. Plus, so plus, and u is e to the x multiplied by dv over dx. So let's differentiate this bracketed term carefully. So when I differentiate minus cos 2x, okay, we're going to have 2 sine 2x. So when you differentiate cos, it's minus sine. So the two minuses will cancel each other out, giving you a plus sign. But remember, you need to multiply by 2. So you're going to have 2 sine 2x, okay? Plus, remember when you differentiate sine, it's cos. So we're going to have a 2b cos 2x. So 2b cos 2x, okay? So I applied product rule, once again, to this term as a whole, e to the x into minus cos 2x plus b sine 2x, okay? So this is by far faster. If you don't do that, if you multiply the brackets first, you'll be using product rule twice on 2 occasions, okay? But if you don't multiply, so if you apply your product rule to this term as it is, you'll be applying it once, okay? So apply your product rule carefully. And don't forget this term here, so plus, when I differentiate 2x, it's 2. When I differentiate a constant, we know it's 0, okay? Now we're in a position to use the remaining condition. So remember, when x is 0, dy by dx is 0. So let's use that condition. So x is equal to 0, dy by dx is equal to 0. So if we use these conditions, dy by dx is 0 on the left, that is equal to minus cos 2 times x, which is 0, okay, plus b sine, okay, 2 times x, which is 0, e to the power x, which is 0, okay, plus e to the power x, which is 0, open a bracket, 2 sine 2 times x, which is 0 over here, plus a 2b cos 2 into 0, which is 0, and don't forget that plus 2. Okay, so we're going to have 0 on the left hand side. Now bearing in mind e to the 0 is 1, okay, so e to the 0, this is 1, sine 0 is 0, cos 0 is 1, okay, so we're going to have minus 1 times 1 from here is minus 1, okay, plus, now e to the 0, this term is 1, sine 0 from here is 0, so 2 into 0 is 0, plus a 2b, and cos 0 from here is 1. So we're going to have a 2b times 1, which is 2b, times this one here is 2b, plus the 2 outside, okay? So if we simplify this carefully, we're going to have 0 is equal to 2b plus 1, and if I rearrange, b is going to be minus half, okay? So finally, let's substitute the a value, so the a value is minus 1, and the value of b, which is minus half, back into the general solution to get our particular solution, okay? So if I put a is equal to minus 1 and b is equal to minus half, okay, back into our general solution, this is what we're going to have. We're going to have our particular solution. So the particular solution y will then be e to the power of x, open a bracket, a is minus 1, so minus cos 2x, b is minus half, so minus half sine 2x, okay, plus 2x plus 1, okay, so that is your final answer. That's your particular solution for this second order differential equation, okay.